So this video is part of the Fundamentals of Electrical Circuits series of videos. We're going to do a brief video on understanding the sensitivity analysis and what does that all mean. The most common sensitivity number we look at is called normalized sensitivity. Normalized means we're going to look at percentage change of one item versus the percentages of other item. So typically I have a system, circuit, whatever, and you have one item you want to change. We kind of call that the controlling element. And so your goal is to find out if I were to change that controlling element by percentage, 1%, then how much would my response change? And the result is usually just a number, has no unit. It's just kind of correlating 1% change in your controlling element to how many percent changes you're going to have in your response, and that is response that you're looking for. So to put that in more concrete terms, let's take a look at an example. Here's a circuit and we want to calculate normalized sensitivity of output voltage with respect to changes in R. Relatively simple circuit. So first thing we're going to do is we're going to go ahead and say, okay, let's say I'm going to assume R is 4K, and I'm going to go off and find what V out is. And so kind of using a KVL, we will be able to write the equation that minus 10 plus 4i plus 10i plus 5i equals to 0, and therefore from here we figure out that I is equal to 10 over 19, more or less. That is about 0.5 milliamp. And then we say, okay, if that's 0.5 milliamp, then I can simply calculate V out as the resistance times the current. So I can use the RI equation there to say, okay, it's 5K times that, so it's 2.5 volts. Since it's 5K and milliamp to multiply gives me volts. Okay, so that's great. Now, the next step for this would be, okay, so let's say then I come along and say, okay, let's change 4K. I could change it by 1%, 100%, whatever is easier. The number of percent changes is really not important. Just to make things easier, I'll change it by 100%. So I'm going to say, okay, I'm going to replace my controlling element R with an R prime, and instead of being 4K, I'm going to change it to 8K, which basically says I changed this by 100%. And now the question, or 1. So if this is 8K, then I can use the KCL equation again. This time I'm going to have minus 10 plus 8i plus 10i plus 5i equal to 0. And then what I need to do is say, okay, then I is going to be equal to 10 divided by 15 and 23, and so we're going to find out what I is, and I is going to be 10 divided by 23, and that works out to more or less 0.43. Great. And so if I have that, then again I can calculate V out prime, the new values of V out based on the 8K, and we'll find out that that's again R times I, so it's going to be 0.43 times 5K, and that is going to be 0.43 times 5, and that is 2.15. Okay, and then I'm going to calculate how many percentages did that change, and based on that we will find out that the percent change here was 2.15 minus the reference, which is 2.5, divided by 2.5. So if we do this calculation here, we'll find that 2.15 minus 2.5, all that divided by the reference, which was or the starting place, which was 2.5, and we've got minus 14%. Okay, so if we want to know now the normalized sensitivity, and of course this is how sensitive V out is. V out is the response with respect to R. We all simply do is take the minus 14% and we'll divide it by 100%. So it will become minus 0.14. What that number tells us that if I were to change R by 1% of its value, then V out will drop by 0.14. So if I increase this by that much, that will go down by that much. And you got to remember, all of these are percentages because we have normalized it. It's not 1 ohm equal to 1 volt, but it's 1% change in R0 equal to minus 0.14% of the other one. So this is in a nutshell sensitivity analysis. It's a big topic and it can get very complex if you got multiple elements and all of that. But for now, this gives us a good perspective of what exactly or what is expected us to know regarding the normalized sensitivity.